So this is the beginning of Unit 5. What Unit 5 covers is rational expressions. All right. And we will go over what a rational expression is and how you simplify them in today's lesson. All right. So this is Unit 5, Lesson 1. All right. Rational expressions and rational functions. This is the standard. And the question we are trying to answer is, how do you simplify rational expressions? So that is all we are doing. We're not adding, subtracting, multiplying, dividing, anything. It is, how can we make it smaller? All right. How can we take this slightly big problem and just make it smaller? So the learning target that we are focusing on is, I can simplify rational expressions just by looking at it using GCF and then sometimes dividing. Some of the vocabulary you'll hear is rational number, rational expression, and that good old greatest common factor, or GCF, that we covered back in chapter 4, polynomials. All right. So, what a rational number is, it's a number that can be written as a quotient of two integers, aka a fraction. All right. So, essentially, a rational number is a fraction. All right. Okay. So, we got 1/4 and or 1/4 or a quarter, -5/3, and then 6/1. Yes, technically that 6/1 is just regular old 6. However, for you can also picture it as 6 divided by 1 or 6/1. We just hardly ever, for simplicity and consistency, we don't put 6/1, we just say 6. Now, what a rational expression is, all right, if a rational number is essentially a fraction, a rational expression is a fraction whose numerator, denominator, or both are non zero polynomials, meaning it's, you can't have a zero, all right, it's a polynomial. It's what we covered back in chapter 4, all right, so it's just a small continuation of that. So we have x squared minus 16 all over x plus 4, 5 over x plus 3, x plus 6 over x plus 1. All right. And what we are going to do in lesson 1 is simply learn how we can simplify these and make them smaller. All right. Or perhaps even neutralize some pieces where it's just an expression and no longer a fraction. Okay. So when we are simplifying expressions, there are three steps, three simple steps. All right. We are going, so the first step that we are going to do, all right, is we are going to factor either the numerator, the denominator, or both. All right. So we are going to factor the numerator and or denominator. That's the first thing we're going to do. The second thing we're going to do is divide out the common denominator. All right, just like we would factor out the greatest common factor in Unit 4, we're going to look at a common denominator. All right, and we're going to divide it out. Divide or cancel it out. So, step 2, divide out common denominator. And then the last step, we are simply just going to write it in simplified form. Okay. So we have a few examples. All right. We have a few examples that we're going to take a look at. The first one is, we're going to take a quick review on simplifying a fraction. All right. And then we'll work up to a little bit more we'll look at a rational expression and then a little bit more complex rational expression. All right. So let's take a look at example A. We have 45 over 63. What we want to do is simplify 45 over 63. All right. Now, there are multiple ways you can do this. You can figure out, okay, what's the same number that can be pulled out of both 45 and 63? All right. Or you can stretch it out into what's called the prime numbers. All right. Simply, okay, what are all the prime numbers that multiply together to get 45? Okay. So there's multiple ways to do this. All right. So one way to do it is, okay, what's the same number that can be divided into 45 and 63? All right. In this case, it's 9. So if we divide 45 by 9, we also have to divide 63 by 9. All right. And then when we do 45 divided by 9, that leaves us 5. And when we do 63 divided by 9, that leaves us 7. All right. So 5 over 7 is as small as we possibly can get it. Another way to look at it, and I mentioned it, is looking at all the prime numbers that it takes to add or multiply together to get 45. All right. So all the prime numbers for 45 are 5 times 3 times 3. All right. That is the set of prime numbers that when you multiply them together, so if you do 5 times 3, that gives you 15. And then when you do 15 times 3, it gets you 45. Or you can do 3 times 3 to get you 9 and multiply that and get you 5. All right. And then the same thing, and what it is for 63 is 7 times 3 times 3. All right. So, and what happens is these bottom 3 right here, these bottom 2 threes end up canceling these top 3s out, which leaves us the 5 over 7. All right. So now the reason I showed you the last one is that's going to be something we are going to have to do when we simplify these rational expressions. All right. We're going to factor out the numerator and denominator. We're going to divide the common denominator, and then we're going to write in simplified form. So we factored out the numerator and denominator. We divided out the common denominator. Then we rewrote it in its simplified form. So let's take a look at example B. All right. We have 2 times x minus 1 and the numerator, and then the denominator we have 3x squared minus 3x. All right. So 2 times x minus 1 is as simplified as it can get. All right. That is it factored out already. Now for 3x squared minus 3x, the factor for it, all right, the common number is 3, and then the common variable is x. So when you pull 3x out of 3x squared, you're left with x. And then when you pull a 3x out of 3x, that leaves you 1, or negative 1. So we have factored out the numerator and denominator. Now we're going to divide out the common denominator. So looking at our denominator, okay, we have 3x times x minus 1. What's common between it and our numerator here is this x minus 1. So we are going to divide them out. They are canceling each other out. Now we're going to rewrite it in simplified form. In the numerator, we have a 2 left, and then the denominator, we have a 3x left. So that is it. That is our simplified rational expression for 2 times x minus 1 all over 3x squared minus 3x. Okay. Now, Let's say, now that's for if you have two binomials. Now let's say if we have a trinomial on top and a polynomial and a binomial on the bottom. All right. We're going to factor both out. We're going to divide the common denominator. All right. And then we're just going to rewrite it in simplified form. So x squared minus 2x minus 15. The factors for it are x plus 3 times x minus 5 all over, and then the two factors for x squared minus 9 are x plus 3, x minus 3. So that's step one. We factored out the numerator and the denominator. Now we're going to divide out the common denominator. So looking at our denominator here and our numerator, so looking at our denominator and looking at our numerator, a common theme is this x plus 3. They both have it. So they cancel each other out. All right. X minus 5, x minus 3, they can't cancel each other out. So we're just going to rewrite it in simplified form. Okay. So our simplified rational expression, for example, C, is x minus 5, x minus 3. Okay. So that's the three examples. All right. What I want you to do is work on these four and then ask any questions you'll need, and then we will see each other again in lesson 2.